So welcome everybody to Rock Your Code, the real world cloud app from start to finish. I'm glad you're all here. If you're in India or someplace like that, I'm really glad you're staying up late to watch me. Otherwise, I guess you can watch the video later. And before I begin, I just want to say that, I hope everybody is staying safe from this worldwide pandemic that we're all dealing with. The state I live in, California, in America, we just hit over 10,000 deaths last night. So, it's getting kind of serious now here. So please stay safe. Please wear your mask. Please listen to your officials. They know better. The medical professionals know better than you do. So please take care, because I want to see you next year at the C# Corner Conference. So anyway, I'm David McCarter. I'm a Microsoft and C# Corner MVP, award-winning developer, architect, consultant, all that other stuff. There's my email address. Please email me if you have any questions or just want to ask me anything about anything. I'm more than happy to talk to you. And my Twitter account, my LinkedIn account. I'm not really using Facebook anymore, so I wouldn't try to contact me there. So I do want to push my latest book real quick called David McCarter's Rock Your Code, Code and App Performance for Microsoft.net. I want to do this just really quick because I've talked about this before. It's available on Amazon. But the biggest thing I want to say is that all proceeds from the book are donated to the Voice of Slum NGO in Delhi, India every month. So if you buy this book, please be aware that 100% of the proceeds go to the Voice of Slum. So please, I hope you buy one, not only because I think all developers need this book, but the Voice of Slum really needs your support. And I was there last year, and that's why I'm doing this. All right, so here's what we're going to talk about today. Opening act, why I'm doing this talk. Architecture and design, which is a really big part of this session. And then we're going to talk about the different layers that I'm going to kind of introduce with N-tier architecture: the data layer, the business layer, the communications layer, the user experience layer, and then encore and on to the panel, where you guys can ask the real experts about Azure. So, all right. I know those videos don't go across the web very well, so I have cut most of them out for you guys. Anyway, I've been a full-time software developer for over 26 years now, and I've always learned best by doing. That's really where I get the most out of learning a new technology or framework or something like that, by actually using it, not reading websites or blogs or things like that. I learn by doing. That means assigning a real project, or as close to real as I can, to myself, and then try to learn the technologies I need to provide that solution. So a few years ago, I set out to redo this talk. And so I decided to, do another Azure application, but then use all the new stuff, 2 years ago that was coming out from Azure. And I'm going to kind of take you through that process and how you're going to see that some of the things I wanted to use, I couldn't use, and I'll explain why. So this project was to teach me more about Azure, because one of my personal goals as a developer is I want to change my I want to change my MVP award to an Azure MVP award. And so any people from Azure listening to this, you can hire me anytime for your MVP if you want, or send me some t-shirts. So let me show you what I'm going to do. So one thing I do like about this session is that it's showing you actually not only how to use the cloud, but to use a legacy application, right? So so this will show you that you can use old apps with the cloud and vice versa, probably. But so this is if you want to call it legacy, I don't think it's legacy because it hasn't been around very long. But this is my utility app that I released, I think about 4 years ago in its first form. This is a video grab of its current form. And it's an app that I developed a while ago for developers just like you. And it's called the .NET Tips Dev Utility app. And I'm going to take you through a quick demo of it. There's only 2 main features right now. Actually, last week, I came up with a new one that I'm actively working on right now. But right now, it has 2 main features. So it starts up first. It makes sure you're not running Visual Studio or something like that because of what it's going to do. And the first main feature that it does is it cleans out all the temp and cache files that Visual Studio, SQL Server creates, SQL Server reporting creates, because all those programs leave stuff on your system, and that can hamper your debugging because things get in the way and you're contacting the wrong DLL. I don't know what's going on, but when I have issues, I run clean and everything goes away. So, but the really big feature that I use every day is the backup feature. And the backup feature automatically scans all of your hard drives looking for all of your projects and all of your code and wraps that up into a quick and easy backup. It won't be quick the first time you do it because it's going to back up everything, but I've added a turbo mode that will back up only changed files. And I'm actually working on a new version right now. So if anybody wants to help me test the new version, please email me there. I only have 1 tester right now, so I need some more, especially in other countries. But you can see there, it's backing up 20,000 files, and it does it pretty quick. Deletion, of course, is a lot quicker. But so that's what the app does. It shows you any errors, if there's errors during especially the backing up process. But what I want the cloud to do, oh no, it stopped. It wasn't supposed to. Anyway, what I want the cloud to do, I'm sorry, it's really hard for you guys to see it, but what I want the cloud to do is there's this little clickable ad down here that people can go click on to buy my books or see where I'm speaking next and vice versa. And there's also a graphic here. And that part of the app right now is hard coded in the resource file. So it's very hard for me to change without doing an update, which is not ideal because I want to do ads that, show up before I speak and then go away after I'm speaking and things like that. So, so I decided to move this part and the management part of it to Azure and then connect to Azure from this app. So this is what I'm going to be taking you through the rest of this session. So, one thing I want to talk a little bit about is N-tier architecture. As I said earlier, I've been a software developer for a long time. And back when I was a beginner, one of the things I learned, and I still use today, is something called N-tier architecture or multi-layer architecture. And, I write every one of my apps in this manner, even testing apps, because I've seen just the amazing abilities of laying your applications like this. And usually at this point, I ask people, why do you use N-tier? And people give me answers, but I'm just kind of show you. But what I want to, one of the things I want you to take away from this, especially if you're an older developer, is you can still use N-tier architecture, which has been around forever, in the cloud. There's no reason you shouldn't use that same kind of architecture. And actually, the cloud lends itself to that kind of architecture anyway. So this diagram is, I taught at a university here for 18 years in San Diego, and this diagram is the same exact one I would show the first day of class of every one of my classes. And it's N-tier architecture diagram. It's the base architecture diagram, a little bit different for .NET folks, but basically this is the base one. And the base of all applications, of course, is the data layer, no matter where it's coming from. Like right now at work, I'm working on, we just released an app for a Fortune 25 company that actually uses Salesforce as its data layer. And there's all kinds of issues with Salesforce, but that's what it is. So all apps have to have a awesome data layer underneath it, and I'll talk about that in an upcoming slide. On top of that, we have what we call a business layer, which includes workflow, components, entities, things like that. We'll talk more about that. Then you have the communications layer, meaning the communication, that data has to get in and out of, that machine or that cloud somehow. And so that's how we do it, through the communications layer. Now, the communications layer 26 years ago, of course, was nothing like they are now. So believe me, a lot easier to deal with. Then on top of that, we have what we call the user experience layer. And this is, the part that users actually interact with some local data caching on the side, hopefully, if you do that. If you're not, you should be. And then alongside, of course, we can't forget identity, because, we have to keep people out of these layers and the user experience layer and things like that. So we need to have some sort of identity somehow. And all of this, every bit of this, as I'm going to show you, except for my legacy app, can live in the cloud, every single bit. So, and that's the great thing that I love about the cloud. So I'm going to quickly go over my feature requirements, because they'll be more clear coming up, because we are short on time. So my goal when I started this project was, of course, to use the latest features of Azure, Entity Framework, and .NET Core, because this was what I wanted to learn more of. And so I wanted to have all the ad data managed by a secure website, maybe make some of that public, operate at the cheapest cost possible, because, that app is free. So, any operating cost is going to have to come out of my own pocket. And then I want to collect basically metadata every time somebody clicks on one of the ads at the bottom of my app. So, I want reporting part of this too. So let's quickly go over the architecture design so we can get to the meat and potatoes part of this. So some of this is going to be a little bit repetitive. So when the app starts, what I want to happen is, in the background, download the latest ads, including the message, the image URL, the link, the schedule, because built into this, I do have a schedule built in. Like I said before, if I'm speaking, I want an ad to come up like a week before, then go away as soon as my talk is over. And I can do that with the schedule. So that's already built into the system. And I want to capture the ad clicks, like I said before. So those are the major overall feature requirements for the app itself. And like I said before, data be maintained by a secure website, basically maintained by me, have reporting for me. And I want to capture the ad clicks per ad by count, and also have monthly, quarterly, annual reports, just showing me which ads are working better than others, or maybe, which things people are interested in more than others. So I need that reporting piece of it too. The database layer, I want to use Cosmos DB, of course. Daily backups, which I'm sure Magnus is laughing at me, but I'll talk a little bit about that later. On the business layer, I want to have my business entities, and I'll go over that in the next section. I'm going to be using microservices, which is an Azure function, and I'm also going to be using Azure Queues. For the communications layer, I want to use the Azure Service Fabric to receive ad data and to maintain the data too. So the legacy app itself will be using the communications layer. The website won't be, but the legacy app will be at this point. The user experience layer, I want to use ASP.NET Core, of course. Show some ads on the main page, have the secure pages to create, edit, and enable ads, and also the reporting. And my goal, of course, is to use Blazor, because when I started this project, Blazor was not out. but it was gaining traction in our world, and so I wanted to use the latest greatest thing, and Blazor really interested me, so that's what I went for. And identity, I'm going to use Azure Application Settings and Azure Key Vault. And other architecture, of course, logging. I actually just finished a Twitter poll about logging and application insights. And I'll probably say this again, but if you've used AWS compared to Azure as far as logging, logging in AWS is a practice in complete frustration, and Azure it's not. So this is one of the reasons I really like Azure. And we'll talk a little bit about that, but not too much, because it pretty much comes for free and not very much work. So that's the first question slide. I don't see any questions yet. Nope. Okay. So the first layer we're going to talk about is the data layer. So I'm taking coffee in my C# Corner mug. Thanks, C# Corner. So here's how my architecture ended up looking like. So I have my database layer in the bottom there. You can see the assembly name there. I'm going to be connecting to Cosmos DB. But whenever I talk about the data layer, I also have to talk about the business layer, because the business layer is where all your business entities should live. And what are business entities? These are like the POCO classes that you use to, use with Entity Framework or other database ORMs or other things. Basically your data models should live in its own assembly. And actually, my data models in that assembly, that's all that's in it. And people ask me all the time, why do you do it that way? And the reason is because so I can use that assembly that just has models in it in all the other assemblies, including the client app. So I don't have to repeat classes and things like that, because that can get really messy, especially with maintenance and serialization and things like that. So it's never a good idea to put your business models here. Never, ever. You always need to put them in an outside assembly, and I just include that as part of the business layer. And whoever said my slides rock, you rock. Thanks. And I just want to stress really hard, I don't have a lot of time for this, but data is the foundation of all apps, and I can't stress this enough. Most apps that I see fail or should fail is because their database is just horrible. And usually the reason why is because a software developer wrote it, which should never happen. But this is the situation, at least where I work. I mean, in the area that I live in. So please hire a DBA that knows what he or she is doing, and start with them first, because they know what they're talking about when it comes to databases. So please do that. So I chose Cosmos DB mainly because it was new, and also because until my first project, sort of like this, actually, this is the first project I've ever used Cosmos DB, and it's the first project I think I've ever used a document-based database. So this was a huge change for me, because I come from the data relational world. And so Cosmos DB was quite a shock, but I wanted to do it. I almost gave up a few times, but with the help of the PM on the Cosmos DB team and others, I kept pushing through it and got through it. So what is Cosmos DB? Like I said, it's a document-based databases, globally distributed, multi-model database, and you can spread the database out in multiple geographic regions. And it scales like crazy. I don't know if there is a scale maximum with Cosmos DB. But I wanted to learn this because this is where a lot of data is going in the world, is to document-based databases like this one. So I did choose Cosmos DB. It was kind of rough in the beginning, but I did do it. So where is my graphic? Hold on a sec. Oh no. It's not good at presentation until everything bombs. Yeah. I think part of that is because PowerPoint, for some dumb reason, decides to do autosaves while you're doing a presentation. But anyway. So here's how you create a Cosmos DB account. It has radically changed. If you saw this talk like last year, it's radically changed since last year. I had to redo everything. And so you just go to Azure, you go to create a Cosmos DB account. You know, the first thing you have to do is pick your subscription. I picked my Microsoft Azure sponsorship subscription, which is part of that I get for being an MVP. I also created a new resource group called Dev App Ads, so I can kind of group everything this app does in one place, so it's easy to delete mainly. And then I need to choose what kind of API that I want to use. And in the beginning, I chose SQL because I'm familiar with SQL, but there's other choices here too, like Cosmos DB for MongoDB, Cassandra, Graph, and Azure Tables too. So you can use those. I just chose SQL because that's what I'm used to. And then down here, especially while I'm developing, I disable the geo redundancy and the redundancy, and the multi-region rights, because this dramatically increases the cost of Cosmos DB. So until you're ready to go live, until you really think about those costs, make sure those two things are disabled. I think they are by default, but make sure you do that, especially while you're developing. And then the next thing I have to do is set up the endpoints, the networking endpoints. I make it public because my legacy app's going to have to use it. And then I also make sure that I make it available to the Azure portal so I can do stuff in the portal, and also for my local PC. And the virtual network stuff I left pretty much default. And then you go to the final page, and it gives you an estimate how long it'll take, and it shows you everything. You press create and go to lunch, because when I did this earlier, probably in March, April, it took 24 minutes during a pandemic to create the Cosmos DB account. Don't ask me why it takes so dang long. Ask Magnus, but it takes a long time. So don't think it's going to be quick. And then after you created your database account, now you need to create your database. And so for this database, I just gave it a database ID of add data. And then I set the RUs to 400, which is the minimum in Azure. And you can see there, it's going to tell me an estimated cost for my Cosmos DB monthly, which in this case, when I did the screen grab, at least it was $138 a month. I must have had some geographic regions plugged in for that one, because it shouldn't be that much just for one database. So choose your RUs wisely. I'll talk a little bit about RUs in the upcoming slide, because if we talk a lot about it, we'll just never finish the session. So once I'm done creating the database, now I have to create the containers. And containers are like a database table. You can think of it that way. So I'm using my existing database ID, which is add data. And the first container I'm going to create is called ads. This is where the actual ad data will sit. And I also created another one for ad clicks, which will receive all the ad clicks from the users. I give it a partition ID, which is kind of like an index. Again, a big subject that we don't have time to go over. And I think that's pretty much all I did. So creating the database, except for waiting 24 minutes, is not very hard in Azure. I really liked, it took me a little bit to get used to the new, flow that they have compared to last year, but it's pretty easy to understand. So next I want to show you my entities. Remember a little bit ago I said that I put all my data entities in its own assembly. Well, this is the add POCO class for this project. I do inherit a base class called entity, which I think right now only has one property name, and that's ID, because everything in Cosmos DB has to have an ID field. And I'll show you that in a second, but everyone has to. So I just made that part of the base class so I don't have to repeat that all over the place. And you can see here, I have my, some of these are enumerations like app. I have it if the ad's enabled or not. I have the URL to the image. I have what language that that ad is for, the link I want people to click on, the message they see on the bottom of the screen, the schedule, if there is one, that's not required, and also the title, which I just use on the website for myself. So you can see there, I mean, the real one has a little more validation and stuff in it, but basically it's pretty simple model class. And I also want to point out, I am using the proper, JSON property attributes up here. Let me turn my laser pointer back on. So you can see, I am using the JSON property attributes up here to make sure that JSON looks proper, because, they're basically the coding standards between JSON and .NET are different. So I want to make sure I make JSON people happy. So when that data goes into Cosmos DB, this is basically what it looks like. You can see all the data that I just went over at the top. You can see the ID, which automatically assigns to any new, new document in the database. And the rest of this is all automatic things that Cosmos DB puts into the data. But the most important one is the ID, of course, because that's how you're going to access that record if you're going to get, that ad, and which I have some code later to show you, or coming up. So I have a data access assembly for this, and I created a base class called data context, which takes any classes in the generic part of it. And in the base class, you'll see on the next slide, that's where all the heavy lifting to get the data, save the data is at, because again, I don't want to repeat that, in every context I want to create for this project or any other project for that matter. So I just put that in the data context and class, so all the other classes that inherit it can use it. So the first one I created was called the ads data context class. And you can see here in the constructor, I send in the three things that this class needs to connect to Cosmos DB. It needs the endpoint URL, it needs the database ID, and it needs the master key. And don't worry, that's not the real master key if you want to go try it. But those are the three things that it needs to connect to Cosmos. And then the only other thing you need to do to get a data context working is just tell it the collection ID. And which I guess that's wrong. It should be ads data because the collection's called ads. So, and that's it. And the class works. You can go after that data all you want. So that's the data context. Let's see what else. Yeah, I already talked about that being the base class. So that's the ads data context class. And here's how I upsert a record. So Cosmos DB, there's no update or insert. There's only upsert, which is the combination of the two. And you can see here that, all I need to do to retrieve an item, to upsert an item, is it passes in the add up here. I do context upsert item async, and then I retrieve it and return it. That's it. Very quick, very easy, couple lines of code, very, very simple to do. And getting data is even easier. One line of code, essentially. So you can see here, retrieving an item by ID is very simple. One line of code. That's using code in the base class. I'm talking one line of code in this class. So that's it. That's as simple as it is in a quick manner how you can get data in and out of Cosmos DB. Now, again, Cosmos DB is a much bigger animal than this. I've barely even scratched the surface of what Cosmos DB can do. So because of that, so you don't make the same mistakes I did in the beginning. Before you sit down and start trying to figure out Cosmos DB, please go take some training. And what I did back then was I watched a Cosmos DB course on Pluralsight. I had to watch it like 2 or 3 times, and it's more of an overview. It wasn't as technical as I wanted, but at least it gave me an overview of just how Cosmos DB works. So if you've never done document databases before, please go get some training before you sit down, because I've been using Cosmos DB for 2 years now, and I'm still having a hard time wrapping my head around document-based databases as opposed to relational based databases. So I'm still working on that. So let's talk about cost really quick. Azure has all these Azure calculators. You can go and estimate the cost of things before you just start going and using them. And especially with Cosmos DB, and especially the way things are charged in Cosmos DB, you really, really need to do this, because it's more expensive than SQL Server. And it seems more complicated to me on how all this is set up. I have a database in a SQL Server database in Cosmos DB that only costs me pennies per month, where you can see here, this one is going to cost me a minimum of $23.36 a month, as long as I keep it to the 400 RUs scalability. So please go check this out before you start using Cosmos DB, or really any feature in Azure. Otherwise, you might be socked with a huge bill from Azure like I was last year. So I want you to avoid those mistakes. No questions? Okay, the only questions I can see are on YouTube. So,
David, there is a question that says, which data client recommended to connect to Cosmos DB?
I'm not the right person to ask. Or what do you mean by data client?
I don't know. I mean,
okay. If they were meaning if you're going to pick between SQL or MongoDB, I don't really have the answer to that question. Yeah,
maybe
I would ask.
Elaborate a little more. Yeah, the question can be framed a little better. Yeah.
Yeah. I really don't know the differences between those different APIs in Cosmos DB. But I'm sure there are some. Probably just the underlying context classes. Any other questions?
No. I just came in just so that you don't feel you're ghosted. Sleeping for 90 minutes, David, is a tough, right?
So you're not really watching. You're just going. You're going to watch TV and then coming back and going to watch TV. I get it.
Oh my goodness, David! I've been here for like the last 8 hours.
I know.
Oh my goodness. Okay.
Okay.
Enjoy.
So we've talked about the database layer. Now we're going to talk about the business layer, which has some things involved in it, including queues and microservices. So in this section, I'm going to be using service bus queues, and I'm going to be using a microservice called Azure function, and that's the assembly name right there. If you get the source code, that's the assembly name. And so that's what I'm going to be talking about in this section. So, beginning my session, I talked about, I have a book about performance, and, the past 3+ years, I've been really focused on, besides code quality, I've been really focused on performance because that's what a lot of people have been hiring me to fix for them. And I've been doing it. So I'm going to share with you a real world way I help performance by using queues. When you're sending stuff to the cloud, as much as you can, put it in queues because it will dramatically speed up your performance. Because those things can fan out into hundreds of functions running at the same time. So it's so fast. It's pretty incredible. You're going to see in the next information. So in this one company I was working at north of where I live here in San Diego, California, I increased the performance of their mobile app from uploading a 600K blob of data from 7 to 70 seconds. Yes, I said seconds, right? To process 600K of data to 500 milliseconds or less for a wearable technology and sports analyst app north of me. And I also want to point out that, most of the code that did the processing of the data itself, I didn't even touch. All I did was put in front of it queues and functions and whatever AWS calls their API management system. That's all I did. And all those things did was still connect to their slow code in the back end. But because of the functions fanning out and the queues, I was able to get it down to 500 milliseconds. And the reason that company hired me is because they made a really big contract with a baseball team everybody in America knows. And, the baseball team was not happy with waiting 70 seconds to upload one bat swing to the back end. So basically what I'm about to show you is exactly how I fixed that problem. So first thing is I'm standing up a queue for all the ad clicks because, not that there's going to be ever 100 people using my app at the same time, but let's pretend there is. And so I need to prepare for that. And the best way to prepare for that is just to put stuff in queues and have functions process that as fast as possible, which is all configurable, of course, in Azure. But that's really the way to do it. And so I'm not going to show you how to set up a queue. It's really simple, but I do have a queue. It's called ad clicks. And there's the URL, but you won't be able to use it because you don't know the security. And then there's other things you can set up like the message time to live, lock duration, things like that. It's pretty standard. You can also set a maximum size for your queue. I don't think I'd ever get to a gig, but that's why I left it kind of normal there. So the one thing I want to warn you about, because I did forget about this again, because I don't do this very often when I set up a queue, is by default, queues are not, you can't get to a queue. You have to set up security for a queue. And this is how I set up security for the send, which will be, the send from the client app to Azure. So you can see there's secondary keys, the connection strings, things like that. But I just want to warn you, don't start using your queue until you set these privileged security up for your queue. And this is the code. It's not super hard. You can see here, I'm sending in the connection string and the queue name. I'm creating a queue client right here. And then all I have to do to send something to the queue, because everything stored in a queue has to be text, basically. So, the best way to do that is just encode it into JSON or something like that. So here's the a message body, and then I encode it, and then I send it async to the queue, and that's it. Very, very simple code. The one thing I want to point out in red here is that you can't, even though this says send async, you can't use a wait on it, which I don't know how this got released by the Microsoft team, but for some reason, a wait does not work on this. So you have to do a wait at the end, otherwise nothing will happen, essentially. So be worried about that if you're using the queues in Azure. And then the next thing I need to do is set up my actual function app. So now I have a queue. I have stuff being dumped in my queue. And now I need to write a function app to basically, be fired off every time an item hits the queue, and then process that data down into Cosmos DB. So this is how you do it in Visual Studio. You just create a new Azure function, and you tell it, you don't have to, but you tell it what kind of trigger you want. I do this just because it makes it a little bit easier to set up. And all you need to do is give it the connection string name and the queue name. And that's basically it to set up a service bus queue trigger. Because I want this function to be triggered every time something hits my queue. So that's why I'm using this one. And I'm going to show you exactly how it works on the next slide in the attributes. So we're just going to pay attention to the top part of this method first, and because the top part is the service bus queue trigger. So the first thing is my function name. That's how you'll see it in the portal, and that's how you can address it. And then the rest of it is the service bus queue trigger. So here you can see add clicks for my trigger. You can see here's this is what holds the connection string up in my app settings. Queue item is actually the message that's being sent to you from the queue. And then it also gives you the iLogger log, so you can log stuff. So that's basically it. This one attribute is basically what sets up the orchestration between your Azure function and the Azure queues. You can do all of this in the portal. I just choose to just do it in the code because, for me at least, at this point, it's easier to do, and I just set these things, and I don't have to worry about anything else. So that's the service bus queue trigger. So remember, everything's coming in under this queue item as text, of course, because I told you everything's text in the queue. And now the second part is I want to show you the Cosmos DB attribute, because this is one thing I love about Cosmos Azure over AWS is stuff like this. So you don't have to use a Cosmos DB attribute, but I do, for the same reason I'm using the service bus trigger attribute, is just to set up the orchestration for me between Cosmos DB and the function, so I don't have to do it in the portal. And to me, that just makes it a lot easier to repeat, setting things up. So you can see here I have my database name, which is not correct. I need to change that. It's adds data. Collection name is add clicks. And I set it to create if it doesn't exist, just in case it got blown away for some reason. And this is what holds the connection string to the database itself. But what I really wanted I want to talk about, which I'll talk about in the next slide, is this right here, out dynamic document. This is where the magic happens in this attribute. And I'm going to show you that on the next slide. But just remember this, right? Out dynamic document, because that's going to come into play on the next slide. So that's it. That's all I have to do to set up these two orchestrations with my function itself. So this is my function. I think this is every line of actual code in my function. And you can see here, I'm always checking to make sure the queue item is, there's something in the queue item. I log, I'm processing it. And then the magic is right here. Remember the document I showed you, the document variable I showed you in the slide before this? Well, all I have to do is say document equals JSON convert deserialize add click message from queue item, and the Cosmos DB attribute basically automatically saves that data down into Cosmos DB. You can see here I'm not doing an upsert, nothing, right? I'm just setting it to document, and Azure takes care of the rest for me. Easy. I love easy. But that's it. That's all there is to this function. The function really doesn't do anything except for move that text data into Cosmos DB. And if I needed to do other processing, you know, like for example, if you needed to do multiple processings on an image or a video or something like that, this is where you would send those out to different places at the same time. But that's another talk for another day. So that's it. So the stuff is automatically saved down into my Cosmos DB. I didn't really do much of anything except for write a couple lines of code. And after that, you need to publish your function to Azure. I'm going to show you the way you do it in the portal, because right now I'm having a problem with Visual Studio. I've been working with an engineer for probably 3 months now. I think I have an Azure engineer and a Visual Studio engineer now working on it, and no one seems to be able to figure it out. But anyway, when I publish through Visual Studio, it doesn't do it. It doesn't do it all the way correctly. Even though it actually gets it there, it doesn't complete and gives you an error. But it's really there and works. So anyway, I'm working on it for you guys and myself, really. But so I'm going to show you how you do it in the portal. So all you do is create a new function app in your portal. You pick your subscription. You give it to a resource group. As you can see here, I'm using the same for all that. You know, I set the function name app, which I'm calling it .NET Tips Add Functions. I'm using code .NET Core 3.1, and I put in the central US. And then I need to create a storage account, which I just left as default. I set it to the Windows operating system, and that's basically it. Oh, and you have to enable application insights. Make sure you do that. Application insights is a lot of valuable information, so make sure you turn that on. And then you do create, and that's it. This doesn't take 24 minutes. It's very quick. Most stuff in Azure is pretty quick, except for creating Cosmos DB. And this is just a brief overview. If you haven't seen application insights before, this is just some of the data you can see in application insights. This is a little bit old. You can see it's from January 2019. But application insights really helps me to drive down on, you know, any issues that I'm having, things like that. And it's so much, like I said before, if you've ever used CloudWatch logs, you pull your hair out trying to figure stuff out. Whereas application insights, it's just really easy to find and drill into things. I think Azure needs to work a little bit to make it even easier to find. I think things have gotten a little bit harder to find since I first started with Azure. You know, the amount of information and data you get, especially if you're using .NET apps, is immensely valuable for, you know, finding problems. And you can use application insights from client apps too now. So I hope to add that to my client app sometime in the future. That's it. Any questions? Someone had one, but retracted it.
Yeah, David, it's with Kamran. He asked, you have implemented your function in .NET Core or in .NET Framework?
.NET Core, yeah. I'd have to check, but I'm not. Well, I know AWS. AWS does not support .NET Framework. I don't know about Azure. Magnus might know about that, but I would definitely recommend moving it to core. Most things should work in core, so I definitely recommend moving to core. The .NET Framework is pretty much dead at this point. So,
Okay.
Yeah.
You can proceed.
Okay. All right. So the next thing, which won't be too hard, won't take too long, hopefully, is the communications layer, exposing your data to the outside world. We have to do this some way. Even in the app we just released for at work for a Fortune 25 company, this is exactly what we do. Everything is exposed through an API, a web API, as we call them. So I had to change the architecture when I came to this, I think last year. I originally wanted to use the service fabric in Azure because it had some great caching capabilities and things like that, but it was taking too long for me to figure it out. I struggled getting it to even work in Azure, and it's gone anyway. So, so while I was working on this, they got rid of it. So I couldn't use it even if I wanted to. So, so anyway, what I ended up going back to was what I knew, and what I knew worked, and that's web API. And web API has been around for a long time. I remember doing a talk on it like the first year it came out. So I went back to what I knew because I know it works, and I know there's no problems with it. And because I just didn't know what other solutions I had in Azure at that point. So I just went back to what I knew. Anyway, create a web API solution. Just go to create a .NET Core API, and always make sure you have configure HTTPS on. Don't ever use HTTP anymore. That's even a recommendation from Microsoft. And that's basically it. So I tried to follow good patterns. So I created a repository pattern in the API app itself. And I just have something like this called Live Ads Repository, which shows me all the current ads. And it takes in, again, the endpoint, the database ID, the master key. And then I connect to the ads data context. I get my live ads, which is one of the things I wrote into that data context, and I return the result. That's basically it. Pretty simple to do once I have all the other pieces, written. Then doing it up in a higher level, like in an API, web API level, is pretty simple and very little code. And then, of course, I have my controller. This is the top of my controller, where I just call it my ads controller. I have a controller base. No, I think, is that for Microsoft or me? I forget. And I give it the configuration. Nothing super exciting there. But again, because I've done work in the repository, now doing this is pretty simple, getting the actual live ads. And I'm just doing an HTTP GET here. These are the two responses I send back, either okay or no content. I'm getting whatever app I'm asking for. I'm setting up the live ads repository. I get live ads, and I return it. That's it. It's pretty simple, like I said, once you have the other stuff written. And reusable. This is why you put things in different assemblies and different layers. So it's really, really easy to reuse. And even someone on my team at work, once she saw how I set things up just like this in our app that we wrote at work, she was going, "Wow, Dave, this is so much easier to make changes." And I go, "Yes." That's why I do a little bit more work up front to save myself a lot of work later. But again, if you've done this as many times as I have, it gets easier to do. So then in Azure, I have to create an app service. So I'm just giving it an app name, picking the subscription, picking the resource group, or creating one, creating my hosting plan. And then I can publish it. And this is the part that's broken right now in Visual Studio, meaning, okay, semi-broken. So when you publish it, it will put it up into Azure, but it will give you an error. And then it doesn't complete a few things that it makes available in Visual Studio. So like I said, I'm still working on 2 different teams to figure this out. So just be aware that if you get an error after you publish, it actually is there. Go check the portal and make sure it's working. And that's it for communications. Any questions? Oh, someone is asking, you don't use Newtonsoft anymore. Well, the cool thing is .NET Core 3 has its own JSON serializer built into it, so you don't need to use Newtonsoft anymore. And actually, based on my code performance book, I forget whether it's deserialization or serialization, that the .NET Core is actually faster than Newtonsoft. So you don't need Newtonsoft for .NET Core anymore. All right. Simon must be watching TV again. So now let's talk about the user experience layer. This is the Blazor fun, I guess. And so I did learn and successfully use Blazor for this project, and Application Insights too. And because I really, really wanted to use Blazor, even I was using it before it was even released, because I see a lot of promise in Blazor. And I'm going to show you why. So Blazor is a brand new framework for building, websites in .NET. Why do we need a new one? Well, I'll get to that in a second. You can create all these things using C# instead of JavaScript. So and this is what's really interested me. A while ago, I kind of moved away from doing front-end work just because of it's just too much to keep up with. And I went to more back-end work, and that's kind of what I focus on nowadays. But so because of that, I just never became a JavaScript expert. Not that I ever wanted to be one, but now I don't have to be. I can just use C#. And there's a server-side and a client-side model, which we'll talk about. Everything renders as normal HTML and CSS, just like anything else. But my biggest thing, like I said, is no JavaScript. I don't need JavaScript. Now, those of you who love JavaScript, you can use it all you want, but I don't have to. So, and I'm going to show you that coming up in a second. So I want to talk about the 2 hosting models, especially since they are both out now for Blazor. So the first hosting model works similar to normal ASP.NET pages, but with a twist. So on the server model, you have your Blazor Razor components in .NET on, living on a server. And then the server then communicates through Signal R to the browser. And that's how Blazor really speeds up the processing, is because now they're using Signal R, which is binary, and it's a lot faster than going through normal methods and sending JSON and stuff like that. So it's really fast. It's very performant at this point. I know they're working on it. But this is basically the magic of the server side, and why it's probably more performant than ASP.NET is because it uses Signal R to communicate to the client. Now, the WebAssembly model, which has just been released, everything lives in the browser. Everything. The Razor components, .NET, WebAssembly, DOM, everything lives in the browser and is executed in the browser. And that's, part of the magic of Blazor is, Blazor can execute .NET, compile and execute .NET code in the browser itself. And that's really cool. But like I said, it's the first version, and um, we'll see. We'll see. I know I've heard some stuff about performance, so I'm sure they're working on that. So here's the major differences. I'm just kind of got to go over them pretty quick. Blazor server, full access to server, fast startup. The code never leaves the server. I'll talk about that in a sec. Supports older clients. It does require, like any other web page, a persistent connection, and they're saying a higher UI latency. I'm not sure exactly what they mean by that, but I want to talk about a little bit about the code never leaves the server. And like I said, this is very similar to, the way ASP.NET works. And the reason I kind of want to point this out is because of the current project that I'm working on at work right now, and security. Because we're in this project, we're hitting, via JavaScript to our backend API, to get data back and forth. And everything worked fine until we had to implement Okta security. And that's when everything screeched to a grinding halt. And so what I'm trying to say is, if you use the server model, you don't have to worry about that. If you use the WebAssembly model, you have to worry about the security issues. So at this point, just because of that, I might only use Blazor server, but we'll see. Blazor WebAssembly runs fully on the client side. It does not require a server component. You can host it as a static site. It can actually execute offline, meaning you don't even need the internet for it to work. It is a larger download, of course. That makes sense. And they're saying a slower runtime performance, probably because of the compiling and stuff like that. But like everything else in .NET, it's probably only slow the first time, and then it's faster after that. So to create a Blazor app, you just go to Visual Studio, say you want to create a new Blazor app, and you can pick the server or WebAssembly version of it now. Again, because of security, I would only pick server at this point for me personally. And of course, make sure HTTPS is configured. And what you're left with is something that looks like any other Razor template in Visual Studio, with a bunch of Razor pages and program and startup. And there's not a lot of difference, really, except what it's using underneath the covers. And that difference is what I'm going to show you next. So, but this isn't one of those differences. So this is a Razor page. If you haven't seen Razor pages before, this is a very simple one for this site. And all I'm doing here is I'm doing a for each over the collection of ads. And for each ad, I'm setting the app, the title, the message, the link, the schedule, if there is one, and the ISO language. So it just loops through here for every ad, and then it just plays it on the page. So this is pretty similar Razor that you've probably used before if you've used Blazor. But what I'm going to show you next is the magic of Blazor. So this is the magic. There's actually two pieces to this I'm going to show you. This is a real C# function living inside a Razor page. And you have this, you create your functions in this functions tag here. And in this right here, I'm just setting up the variables that the page is using. And there's the ads collection, and there's the ads clicks. So those are the two variables I'm setting up that the page will use. And the next, I'm going to show you the functions. Sorry, the function that populates this data. There we go. So this is the function. So there's the variables that I set up. And then what I want to do so the page populates correctly is on init async, I'm getting my data. So all I'm doing is doing an await HTTP GET JSON async. I'm giving it the URL, and then I'm getting the, this gets the ad click count. And then I'm doing another one to get the actual ads itself, and I'm sticking it into the variables, and that's it. That's all I have to do. That's all the code I had to write for this page. Pretty simple. And I'm not using JavaScript. Woohoo! Well, I'm not really. So, like I said, if you're used to using Razor, then this would be pretty familiar to you. And so now I'm going to show you the demo of the actual site itself. So I'm going to show you the demo. I'm just going to show you the home page, which I might make public, the ads list, and how I edit and add ads. And the site you're going to see is the basic Blazor template. I didn't do anything to the colors or how the look and feel or anything, because I just don't need to, because the site is basically for me. So I don't need it super fancy and super fancy logos and stuff like that. So here's the main page. And you can see here when I recorded this video, I only have 2 ads. I have one in English and one in German. You can see there I have the links. There's no schedules, what language it supports. And that shows me the top ads. This shows me all the ads. And here is where I can instantly enable or disable ads. And I can edit ads too. And the editing and adding ads is basically almost the same exact page. So here I'm editing an ad. I can go in and change the text and the length and link, language. The one piece that's missing in this video is the piece that you set the URL for the image, because that's actually an architect change that I did after I recorded this video. And then create a new ad. All I have to do is create ad. It's pretty much the same thing. I can set it enabled. I can give it a name. I can give it a message. I can give it a link, and I can give it which language it supports. And everything will default to English, but then if I have German or other languages in there, it'll go to that one instead when you see it in my app. And that's it. And I added a new ad. Nope. I think I need to. No, I don't want to ever delete an ad. But that's basically it. That's the site. And once I learned how Blazor worked, because I was familiar with Razor pages before, doing Blazor wasn't super difficult. I think I did. I know I did some research on Blazor first before I started doing it, but as you can see, there's not a lot of code. There's not a lot of work. That's all handled through, Blazor and ASP.NET. So that's the user experience part. Any questions?
Not this time.
Okay, I'm trying to hit my 1 hour 30 minutes, so I think I'm going to make it, because we're in the last section. We're in the last section now.
Mm-hmm.
Now you can have some rock music. Okay. I don't want to bug you guys too much with rock music. So I'm still working on this app. Through the pandemic, I've been working on some of these issues, with the Azure team and the Visual Studio team. So I have been kind of behind on what I want to get done, just because of issues I've been having and the pandemic and everything else, so. So I'm still working on some stuff. I still need to add the box to put in the image URL. I might change some of the security around. We'll see. I need to hook up the ads to the client app, which will be super simple. Right now, I'm actually writing I'm going to cache all that data down onto the machine, just in case they can't go out and get ads for some reason because the internet's not working and stuff like that. So I'm working on the caching part right now. And after that, it'll be super simple to set up, because I've already created an assembly that I'll probably release as a NuGet package to connect to Azure queues and other Azure endpoints. And I haven't done any reporting yet either, because it's not really in use yet. So as soon as this goes live, I definitely want to do the reporting. And speaking of that, I said earlier in the talk that if anybody wants to help me unit test the new version of this, which will be part of unit testing this cloud piece, please email me at .NETDave@live.com so I can put you on the testers list. And you know me, I'll probably send you some swag and bumper stickers and stuff like that if you help me. I never forget the people that help. Hindsight, I might go back to SQL Server. I doubt it, but if cost is really a big thing, Cosmos DB might not be the greatest thing for you, and SQL Server might be. But I do want to stick with Cosmos DB at this point. I do want to learn gRPC instead of maybe using Web API for the API calls. So again, something I might do in the future, but right now it works fine. So here's the final architecture. You can see I have my client app goes down into my communications layer, and then down into the business layer, database layer using Azure Functions, Web API, Blazor, identity using Key Vault and other stuff, Cosmos DB, Service Bus Queue. So this is everything together for this app. And as you saw, the app isn't really that complicated. It's not really that big of an app. But, when you layer things out like this, I can build upon it. And that process will be a lot easier than if I didn't layer it out in this N-tier or multi-layer, multi-tier architecture. So, one of the things I wanted to prove in this talk, not that a lot of you younger developers out there have ever heard of N-tier, but, I wanted to prove to developers who've been around for a while that you don't need to abandon, something you've learned for many, many decades. You can still use the exact same thing in the cloud. There's no reason not to, at least to me, there's not. So I hope I proved that point. I hope I gave you a general overview on how all these things can connect together. And oh no, Blazor will not end up as another Silverlight. And I probably know some legal reasons why, but I'm not going to say that live. So, so that's it. I have two resource slides. I'll let you do your screen grabs. There's where you can get the source, though it's probably old. So if you want the latest source, let me know. I wrote a whole series of articles about this on C# Corner and my site about this project from beginning to end. And you can go read those articles. This talk is basically based on those articles. You can go read about my app on that URL. You can't download it right now because Click Once is horribly broken, and I'm just going to have to zip it for now. And also, please check out my really good friend Carl Franklin's Blazor Train. He's every week is doing training about Blazor, and he's always showing really new cool stuff. And Carl's been around as long as I have, and he's a really great guy and a really great trainer. Here's some other links for you to getting started with Blazor. Introduction to Cosmos DB. Please read. Please make sure you use the Azure cost calculators before you start doing stuff in Azure, especially if you care about the money coming from your own pocket. And also, I found this serverless functions course on Pluralsight useful too. Again, kind of like the Cosmos DB, it's more of an overview. I wish they would do more technical sessions for serverless functions. I hope Pluralsight will, but this one gives you a good overview of how to do it. And before I go, I do want to promote my new project, and that's called the Hello World Cookbook. And the main reason I did it was because I want to try to raise even more money for the Voice of Slum in India. And so I have a brand new book that's not even tech related, sort of, about cooking. I've been, a chef at a restaurant since I've been 18 years old. I've been cooking ever since. I'm constantly working on recipes. I've even come up with recipes like when I come back from India to kind of remind me of my trip in India and stuff like that. So I wanted to get, recipes from tech-related people from all over the world and put it in this book called Hello World Cookbook. So I'm working on it. I hoped it would have been out this year, earlier this year, but I still need your recipes. So please send me your recipes. 100% of all proceeds of this book will be donated to the Voice of Slum. I don't make a dime off of this. And I'm also looking for help with to unit test the recipes, for graphic arts help with the book too. So this is a volunteer way of getting the book out. And that's it for me. I hope you liked the session, and I hope you'll stick around for the Q&A after this, and have a great rest of your weekend.